All right, here's another practice problem. So suppose we have a fair penny. All right, so that's sort of a key word. We have a fair penny that lands on heads and tails equally when we spin it. Then suppose that I spin the penny 250 times, lands on heads 103 times out of the 250 times I spun it. I want to create a simulated distribution. That means I want to put it in the applet and use a computer to create a distribution of the sample statistics, assuming there's a set of things that are true. All right, so let's kind of carve up this problem. I want to use my population and parameter sample statistic. Does it say mean or average in this problem? No. That means automatically I'm dealing with a pi and a p hat, which means I'm dealing with proportions of success. Proportions, fractions, percentages, decimals. All right. So I have a fair penny. So this is one of those sort of games of chance type things, right? If I have a fair penny, we know in the long run that it says that it equally lands on heads and tails. So in the long run, I would expect to get heads half of the time, or 0.5, or 50%. So this is the long run proportion of spinning and getting ahead. So that goes with my population. Whenever we have something that is a long run or sort of a theoretical value, that goes with the population. So the population would be spinning ahead in the long run. My sample is here, I spun the penny 250 times. So n equals 250. So spinning the penny 250 times. And actually, let me just modify this. This is not spinning ahead. This is just spinning the penny in the long run. Spinning a penny like infinitely in the long run. All right, so if I'm going to put it in the applet, I need a set of assumptions. I need to tell the computer what to do. So what I want to do is I want to create a distribution assuming that the population and the parameter are true. So the population parameter, in this case pi is equal to 0.5. My sample size, I want to use the same sample size as I use in my sample, n equals 250. And then I'm going to repeat it a lot of times. I don't know if this asks for, this one doesn't really ask for how many times to do it. So you could just spin it 100 times. What will happen once we do that? We're going to get a distribution that's going to be centered near pi, near 0.5. Okay, so it's going to be approximately equal to 0.5. And then we want to compare our sample statistic, our p hat. What's our p hat? Oh, let's put it here. P hat is the proportion of success. Okay, well, we got heads, that's my success, 103 times out of 250 spins. That's my p hat. So when we go to the one proportion applet now, sort of have it all sorted out, what should be entered under the probability of heads? Well, that is this, my population parameter, 0.5. What should be entered under the number of tosses? That's our sample size, n equals 250. And then the simulated distribution of sample statistics is going to be centered approximately at what value when we collect proportion of success. So either have proportion, what it shows here is not a fraction, it shows the decimal form. So it's going to be approximately equal to 0.5. And then if we switch to number of successes, what would that value be? Well, proportion of success is equal to number of successes divided by the sample size, n. In this case, the center is 0.5, so we're going to put in 0.5 for proportion of success. We don't know what number of successes is, but we know what n is. It's 250. So how are we going to figure out number of success? We're just going to solve for s. So we're going to multiply both sides by 250, and we would expect the number of success to be about 125. So if I spun the penny 250 times, in the long run, I'm going to get heads 125 times. 0.5 times the number of times I spun it, 250, because I know half the time in the long run, I'm going to get heads, which is 125. So let me pull up for a second my applet. So here's the one proportion applet. I'm going to put in my pi here, that's 0.5. The number of tosses is my n, that's 250. So when I enter it, that's my sample size. And then I can just repeat it 100 times. I'm going to draw the sample. I'm going to start off with proportion of heads. So if I draw the sample, I can see here that my mean is about 0.5 because I told it to. I wanted to generate a distribution assuming that I had a fair coin, assuming that pi equals 0.25. I take sample size of 250 and then I have 100 dots. I repeat that 100 times. So if I want to switch to number of heads here, you can see it's about 125. All it did was take 0.5 times, or here, let me go back here, it took 0.502 because this isn't exactly equal to 0.5, right? Because it's going to be different each time. Go to number of heads, it's going to almost be equal to 125. But all you need to know is this formula here. Proportion of success is equal to number of successes divided by sample size. And then you plug the numbers in and solve for which one you don't have.